Welcome to stream number 41 in a series about programming the original Nintendo Entertainment System live on Twitch, Mondays and Thursdays, 9 p.m. Eastern. So we've passed 40 episodes. The channel on YouTube has passed 200 subscribers, which is pretty cool. I'm excited to see that people are interested in NES programming. As I mentioned in the last stream, I am putting out some videos that I am calling the Zero Page series. I put out one episode of that along with a supplemental episode for getting CC65 downloaded and installed on your machine so you can start building code. The next episode will be related to programming and specifically how different number systems are used when programming, so decimal, hexadecimal, and binary, and why they're important and how they are interrelated. Haven't gotten to that yet. I've been a little bit busy, and the last stream we got our attribute updates working, and they're not certainly the most efficient. They could be, but we can go back and optimize them. They're good enough for us to start working, and then to start working with other stuff, and then we started looking at Messen, which is another emulator. Previously we had been using FCEUX, and I had been talking to some people on the awesome Discord at Nintendo Age, the Discord channel, and discovered that Messen had some cool features that people were recommending, but I had no idea. I was shocked at how just how awesome it is. So I was further shocked to find that after posting that video, the recording of that stream on YouTube, Sour, who makes Messen, a person who goes by the name Sour, he found my video. I assume it's a he. I believe they said on Discord it's a he. He found my video and added some additional insights to what was going on with what we were looking at in the emulator. Just additional things that made me go, holy crap, we have to continue to use this. So by default, the emulator is not set up to show these debugging menus, but if you go into the options and the preferences, you can enable developer mode. So this is what it looks like normally. If you go into the preferences, you can enable developer mode, and then all the debugging menus show up here. Apparently, all of the shortcut keys, let's see, are configurable here. So if you want to change how certain things work, that's configurable. He mentioned that the way the emulator works is a little bit different than some of the other ones in that it is particularly harsh in the way that it initializes the prog and char-rom configuration in MMC3. He said that was done on purpose because that's more like real hardware, and I think that's good that it does that, because I mean, when you go to put the game in an actual NES, it sort of has the same issues that we're seeing here. One of the things that he mentioned was that you can also randomize. Now that may be in the next release, I don't remember, but you can make it so it randomizes the banks that are selected when starting up. The idea being that, again, it's more kind of like the real deal when you go to run your code on real hardware. Oh, so okay, and then you can you can configure these shortcut keys too. Wow, awesome. This is, yeah, so this is going to be what we use from now on. And then one other thing he pointed out is that, so this mode where it's showing the source, this is a disassembled mode where it is taking the code and linking it to the symbols and then kind of displaying the code based on what it figures out. You can switch to source mode here, and it is then literally your code, which is, again, pretty amazing. You know, this is the kind of thing you see in something like Visual Studio, which, you know, is made by Microsoft. So huge amount of money put into it on the Microsoft side. Sauer has done an amazing job with this, so definitely recommend you guys switch over to this, because this is fantastic. And I like this too. You can if you're using debugger mode, disassembly mode, you can look at you can just highlight and look at what the code. Oh no, sorry. It'll show your original code side by side with the disassembled code, just as like a point of comparison, which is kind of cool too. So I'm just going to switch to source view so it shows our code. The last thing he mentioned was that the option or the tool for running the assembler, he said that there's some sort of bug with this right now in this version and that it's broken. And so he said that that'll be fixed in the next version that he's working on, but that's why I kept having weird issues where it wasn't updating these banks properly, or the way that we or the way that I was expecting it to. So what I think we want to do right now is we want to work on getting the char viewer to show the appropriate banks that we are expecting, kind of like what FCEUX was showing, but we're not seeing that here. So let's start with that. The other thing I wanted to do was, I realized, kind of after thinking about how we're building this, that I probably want to change the configuration so that I'm not overriding the default NES type with MMC3. So I'm going to change this to MMC3, and then we're gonna make the default NES configuration available. I don't think there's anything in here that yeah, so it's just the file name that identifies it. I thought there was a way to go to the source folder. No? All right, well. So I'm going to rename that to, let me close this. So this is NES MMC3. And the only reason I want to do that is because I think, you know, thinking about it for whatever our next project is going to be, I want the basic configuration that it has here to be, you know, available without having to go and break my MMC3 configuration. So this should all still build correctly. Invalid target NES MMC3. MMC3. Do I have to put this in a file somewhere? Doesn't just look at the names. Module config. No. Boo. What is this doing that it's not just using the file name? NES MMC3. just doing something dumb besides closing our game? This is from the zip file, so that's no longer relevant. Shooter asm. Make file. Type NES MMC3. Config NES MMC3. I would think that it would just, hey Vestrak. I don't see anything that actually names this. Is there a way to invalid target name NES MMC3? Is it hard coding the name? Or is there something in here that it's looking for? Oh, is it? Do I have to? No, these are just, it just includes. Don't need that. What gives? Alright, well, I'm not going to waste any time on this right now. What I'll do is I'll just switch it back and I'll take a look at this later. We have more important things to be wasting time on. That's what the verbose flag does. Okay. All right, so if we go back to this and restart, everything should look good and not have any problem. Okay. So just like we needed to set the register here to initialize the mirroring, we should initialize our our swappable jar banks, right? Get, and then so we want to set up the char banks properly, and so that would be 0, 1, 2, 3, 4, and 5. I'm just going to set them sequentially and see what happens, because I think that's how our data should be organized anyway. I'm still not real clear on exactly what this all is referring to. Like, I get that if this bit is turned on, it has apparently different meanings. But it's not, I don't know, it doesn't, not super clear to me from this explanation, but anyway. So let's store it in 8000 and then load A1, store A 8001. And let's see if we see bank 1 in the PPU viewer here. So the char viewer, the data is right, the palettes are weird. Zero, one. So this didn't change anything as far as I can tell. I'm not sure what that did. Oh, it created breakpoints. Never mind. Okay. So let's see if I can do this. Turn on this breakpoint that we, if the CPU is writing to 8000, we want a breakpoint. Because I still want to see, I want to see if it actually picked up the code change. It did, okay. Alright, so it definitely changed something. Because now the title screen is wrong. Let's see what it did. Looks like it changed this. So it changed bank 0 to that. So let's change that back to 1, and then let's do bank 1 to 2 and see what that looks like. I did a little reading on this this week, but it was a little bit busy, and the reading that I did was not exactly that helpful. Okay, so that looks like what I was expecting. And this stored 1 and 2 in the charon banks. And let's see. I guess the question is, what banks does that map to? So 7FF. I guess those are not, those must be program banks. And if I go to the PPU, does it show? Well, oh, are these? So that's A0. Okay, these are the timer. This is 8000. Let's see here. Oops. Help. Char banks. PPU viewer displays the name table sprites, char banks, and palettes. PPU viewer, debugger, labels, rows shown in gray. Let's take a look at what it says the bottom is. CPU, PPU memory mappings. CPU and PPU memory mappings are visual aids that display information about the current selected prog and char banks and the name table. The banking configuration represents Messon's internal representation of the mapper in use, which may not exactly match the mapper specs. For example, a mapper with 2 times 8K plus 16 is emulated as 4K, 4 times 8K internally, so it will appear as 4 8K banks. I guess the question ultimately, though, is, does it say? Okay, so this is a name table. All right, so those are the name tables. Those are the MMC3, 8000, C1000, E1000. That's workgram, which we're not using. This, I mean, it's showing this is right. Obviously, the sprite mem is still not exactly right, because we should be seeing the actual sprites. Oh, that's interesting. So it's actually showing. It's actually showing. Wow. So it's actually showing these tiles with the colors based on how they're displayed in the name table. Holy crap. So the colors are changing based on the name table attribute settings, and reflecting that so that you can see what it looks like with that color applied, instead of having to switch around automatically, or manually I should say. That is pretty cool. Alright, so that's looking correct. I guess, you know, I want to step through the code and look at if I see anything in the bottom here changing when we write those bank switches here. So step over. So this 0 1 0 1 0 0 0 0. So it's alternating 0 1 and then a bunch of zeros. And that still seems to be the case. And that still seems to be the case. So, oh, and that changed to 2. That one changed to 3. Okay, so let's see. So I had written. So if when this is when 8000 is ANDed with 80, if it's 0, so that's this, then the value of MMC3 register R0 and FE, R0 or 1. R1 and FE. Is that what it's going to change the value to be? Is that what that's telling me? And then when you write 8001, you're giving the new bank value based on the last value written to the bank select register, which is above. So if we're selecting the char banks, this is what we're looking at, which is what we're doing. We can change the program banks too, but we're not interested in doing that right now. Let's see. But yeah, the documentation on this is not exactly as clear as I would like it to be. So if I do that right now, I expect, with no actual certainty, that we might see our sprite stuff appear here. But we'll see. So we'll step through. So I didn't expect that to do anything because that looked like that was already correct. That looked correct. It seems to have changed. So we have 0 and 1, 2 and 3. And then the next one, I guess we'll update that sprite, that char memory. And I guess, let's see, what address is that? That's 1,000. So that would be good because that's what we're looking for. Question is, of course, what is it going to update it to? It updated it to 3. Now I had written 3 to it. I guess the weird thing is it's applying some sort of logic to it, which is not particularly clear to me. Is it using a bit pattern? This is going to be one of those things where I feel like once I figure it out, if I put out a 0 pages video on this, it's going to be really helpful to people because it's not exactly super clear. Alright, so make that 2. If I make that 4, and I store it, we actually get 4. Oh, and then we get our sprites. So now the game should actually have, oh, it has this ship sprite. That's pretty cool. Let me slow down to an actual proper speed. There are bullets. We don't have our colors properly established, but that's okay. So now our name table, or I should say our char table setup is correct. I'd really like to understand exactly why that is. So let's take a look back at this documentation here. I mean, the good news is that it's working and we actually have our sprites back correctly, and I have no doubt that when I look at this on the NES, this is going to be what we actually see. So this is the Sprite Viewer, which is kind of nice because it shows you, okay, this is what it looks like on the screen, and then these are the individual 8x8 sprites. And right now we're not doing any sort of horizontal or vertical flipping, but we could if we wanted to. And then we would be able to save some char RAM, but we're not doing that right now. Or char ROM, I should say. So these are all pretty straightforward, and you can see that it's set up that it could show an 8x16 too if we were doing that. And then all of these other ones are off the screen. That one is, I guess, down and not visible. All right. And then this is the other cool thing. You can actually, if you want to, you can change your current palettes and make it a new set of colors. So if I decide I want to see what this looks like with the pink instead, or this color, I can do that in real time, which is kind of nice because it lets you play with the colors and get a sense of what it looks like. All right, so excuse me. So what we did to make this work was we wrote 0 to 8000 and 1 to 8001. Then we wrote 1 to 8000 and 2 to 8001. And then we wrote 2 to 8000 and 4 to 8001. So we wrote 0 R0. See, like, that's the thing. Like, R0, is that this as register 0, or is that, like, what is that? There's no definition of what register 0 actually is in this context. So when it says that when the value of 8000 is 0 when ANDed with 80, you get R0 and FE for the value of MMC3. Like, what the hell does that mean, right? And then this is the new bank. Zero to 3 FF, 4 to 7 FF, which all fall within this range. Oh, is it are there multiple ranges, and R stands for range? I still don't quite get why that worked. I'll do some more research on that and see if I can give a good explanation. I mean, it works, and it's, you know, we see our char ROM here, and, you know, great, but it's not clear why exactly that is working, at least not at this point. Okay. Well, so now I'd like to make it so that if you fly into a wall, your ship gets destroyed. We can do enemy collision 2, I suppose. But I figured the map collision will probably be tougher to do well. Enemy collision is essentially pretty straightforward, at least conceptually, right? We're dealing with the ship, and the enemy is flying, and if there's an overlap in their areas, then the player, you know, gets damaged, right? Pretty straightforward. With the walls and stuff like that, we have to figure out if we're going to do it at the metatile level, or are we going to do it at a sub-metatile level? How is that going to work? We could start with one and see how it goes. So first things first, let's go to tiled. Let's change our map. So we had made this map work this way so we could test our attribute stuff, and we don't need it to be this way anymore. So I want to make this I can no. Oh, there we go. Thought there was a way to multi-delete. So the question, first of all, I guess becomes, do we want to make it so the meta tile itself is considered the trigger for collision, or should that be separate metadata about the map? And part of me says it should be separate data about the map, because having it kind of coded into the meta tiles, well, I was going to say having it coded into meta tiles is limiting, but at the same point, making the game inconsistent about how it represents certain tiles as being collidable or not collidable might be problematic. Also, it would be nice if we had some real assets here soon. So I'm going to try and figure out if we can get something something a little bit more interesting to use for a map here, or for meta tiles, but haven't gotten there yet. So let's re-export the map here and bring it back over to the project. Don't need that. Don't need that anymore. And just going to kind of pull everything over. And we'll reassemble it, and we'll reopen this. Make sure that that loaded right. Yep. Okay, so kind of made that narrowish passage for the player to have to fly through, presumably with enemies in the way and having to shoot them down. See, there's some interesting glitching going on with the entities. I don't know if you can see that in the stream or not, but if I slow it down, we'll probably be able to see it. I don't know if you saw that bullet do a little jump. I think that's probably related to the NMI taking a lot longer than normal, and so some of it impacting the game loop potentially when there are a lot of entities to process in the game loop, and a lot of sprites to render or enable, really. So anyway, all part of the optimization we'll have to look at some point here. But to start off with, what I want to do is, if I go over here into the green, it should destroy my ship, right? So I'm still, what we can do is we can make it encoded into the meta tiles and just say, yeah, I mean, you know, green tiles collidable, purple blue tiles collidable, maybe the solid blue tiles are not for some reason, right? And so if you are over one of those meta tiles, then your ship it crashes. I mean, it'd be more interesting to be able to do. It'd be more interesting to do collision at the individual tile level, because the 32 by 32 tile size is pretty coarse. But the problem is, if we do end up with a less coarse breakdown. So basically what that would look like then is we would say, okay, if you have one meta tile, right, that actually looks like this. It's composed of 4 tiles by 4 tiles. And what we would say is, okay, well, let's say we're I don't know, let's say that we are building some sort of system of pipes that we're using. And so the system of pipes consists of an angle piece like this, and then there's another meta tile up here. I'll switch colors for the actual components. So there's this red piece here, and then within this there's another large piece of pipe, right? And then next to both of these there's this meta tile. Go to the red here for that, and it curves this way. Now there are ways that we could probably avoid this, you know, as far as the visual design goes, where we won't have to worry about this problem, but realistically, you know, maybe there's a reason we need it to work this way. And so the problem is that, you know, now all of this, if we're only doing collision at the meta tile level, all of this area, which should be non-collidable, right? And even arguably maybe this one tile, because, you know, it's pretty, you know, it's pretty a small sliver. Maybe we look at this and we go, you know, we don't want to extend it out that far. We make these non-collidable too, and then we move the pipe graphic down like this, right, so that it kind of matches on a seam a little bit better, and then we don't have to worry about that here. Am I using some sort of clone mode here? That's weird. Why is it doing that? Anyway, the point is that if we have only collision at a coarse level where we're doing it on the meta tile, well, then you can't do something like this, because basically it's like if there's something that you can collide with in the meta tile, then the whole meta tile has to be collidable and considered something that would damage the ship. Not ideal. But of course then the flip side is, whereas, you know, if we look at our meta tile configuration, we have 8 by 7 or 8, depending on how you want to look at it, right? So it's only 56 collidable points that we're looking at and looking into. On the flip side, we are now talking about 32 by 30 at any given point that we're, you know, investigating and have to look at for collision. And unlike our other data that we're streaming in as we go, so for our screen, if you remember, for our level, even though the level might be this much bigger level that, you know, is many screens tall, as we scroll up, we are loading the first screen in one piece, and then we have strip by strip the rest of the level saved out in the file with the palette attribute information, so that we don't have to, in the NES, sort of backwards calculate the level or store it totally reversed or whatever. It just kind of works out better that way. And it's easy to work with. So now we have to have this 32 by 30 kind of granularity if we want to do this. Now the good news is that we can actually do that without having to store a 32 by 30 visualization of the map. What we probably can get away with doing is having this 8 by 7 at all times, and when we look up, okay, where is the player in this 8 by 7 grid, we can say, okay, if the player is over here, which meta tile does that match up to? Okay, that's this one here, right? Okay, so where does the player fall within that meta tile? Oh, the player is here. That's good because that's not a collidable spot, although pretty soon that's going to change. So there's kind of this dual lookup that you have to do. And similar to how we're calculating the, or I should say similar to how we should be calculating the lookup of each of these rows only, each of these rows of meta tiles only once per transition from one meta tile to another. Right now, we're looking for the meta tile every time, and then looking at which row we need to load within the meta tile. So the additional work that we would have to do to make this work is we'd have to have this 8 by 7 buffer of the current meta tiles that are loaded, which that's not so hard because we'd have 56 bytes, and we'd have a position into this, and just like we were kind of doing with the attributes, we'd go one row at a time. As we do an update, we'd update that buffer with a new set of meta tiles as we load the meta tiles. Now, I'm wondering if this can help us. No, this wouldn't help us. I was wondering if it would help us with what I was talking about here in terms of not looking up the meta tile row, or not looking up the meta tile row every time. Well, I guess it would, because what we could do is we'd say, okay, this is our pointer, this is where we currently are. We've loaded these meta tiles in here, and we'll just keep looking at this position until we go, okay, next meta tile row, the pointer goes over here. This is no longer where the pointer is looking, and we just keep looking at this until we go to the next meta tile row. That could work. And then of course when we get to the top and we underflow, or whatever you want to call it, we reach 0 and we go back to we go into the negatives, then we need to flip back over here to that part of the memory buffer. Maybe that's what we'll do. And that'll get us started on optimizing how we're looking into the meta tiles, and then from there we need to be able to define collision on each of the meta tiles with the subtiles. I don't know how far we're going to get on that today because I'm exhausted. Let's start with this buffer part. That should be relatively straightforward. So let's call this meta tile buffer, and that's 56 right? I'll take a look at something here. So in theory, I should be able to let's see. Address 40. So that's cool. So I can actually see what the address is, and then can you... Okay, so that looks for that. What is the table file? Oh, can you do... That's a search string. Okay. Can I just like... I mean, I'm kind of asking for a lot here with what I was... Just the fact that I can... Just the fact that I can go to it and see, okay... that's where... Oh, you can find occurrences in your code. Oops, I didn't mean to do that. Where did my... Oh, I see, show comments, got it. Metatile buffer. How did I do that before? What did I... Edit? Oh, okay. So that gives me the address. Okay. So let's do this. Let's similar to where we are loading the attribute buffer, we need to do the same thing with the metatile buffer. And then what we can, let's see, that might work. So store a metatile buffer X. That seems like that should work. Oh no, wait, nope, that won't work. Close. Load a sprite mem Y. Actually, let's do that. Store a metatile buffer Y. So we're just basically saying, okay, we got the value of the metatile. Let's just store it in metatile buffer, and then let's see how that looks when we actually look at that here, right? Because we need to do that initial population of the memory. Going into it here, so go to 40 and it'll load the level. Oh yeah, that's cool. We broke it. How do we break it? Well, that is fine because that's we're shifting it by 32 to find the lookup, or not by 32, by 16. Am I just being dumb right now? Store A, address with Y. It's just a store within an offset. What does I not like about that? What did I... Let me just make sure I didn't accidentally modify something that I didn't mean to, so walk that back here. You know what? Before we do that, we haven't done a commit in a real long time, so let's do that. So, yep, our make file changed. So let's stage that and say updated make file to generate debug out information for Messin. Let's commit that change. Stage that. Added some additional information for profiling entities. This is currently not working because memory has been shifted around. And then of course this. So we've done a ton of changes to this. You can see that by scrolling through and looking at everything we've added and modified in some way, shape, or form. So that's pretty cool. Let's see, levels load with fixed 4-color max palette. Attributes are loading as new rows get populated from meta tiles. All right, cool. So we're in a good spot to start making. Oh, you know, I didn't even comment about MMC3. That's all right. So yeah, so let's do store A. Attribute, what do we call it? Meta tile buffer Y. Store meta tile value in buffer for lookup purposes. This is still going crazy. So it does not like my storing. It doesn't like it being stored in meta tile buffer. Why? Why is that? If I don't do that, it works fine. Okay. I must be writing too many times here. My guess is this is probably writing one too many rows. Like if I make that 56 to 64, this will probably work. Yep. So that was it. So we're writing 8 meta tile rows. Is that right? Are we actually doing that in the asset tool? I thought it would just be 7, but well, no, we're doing, well, so we have the 64. Oh, is it loading the attribute data simultaneously, and that's why we're getting 64? Let's see. Yeah, it is. Well, that's for the next attribute, but that's at the end. Attribute buffer. tiles. Check tile Y branch not equal. Load tiles. Where's that? It's at the top, right? Yeah. 1E. $30. Let's check to see if we're done with screen 1 and need to load the attributes. 1E. Oh, okay. So it's gonna load. It's technically not loading 8 per. Well, it is loading 8, but it's not. It's not. It's like 7.5. So, right, because the first row that we see 1, 2, 3, 4, 5, 6, 7, 8. In messing, what are we seeing here? We're seeing that. So, and that's already been loaded. So, what did I say? 1, 4, 6, 7, 8. So we are seeing 8 there. The name table. Did the name table have to load that already? So 1, 2, 3, 4, 5, 6, 7. So it only loaded 7. It's weird. So why? Why the extra bytes? And temp sprite mem y. Where is it increasing y? Load tile x. Transfer a to y. Get sprite mem. Okay, because we're actually not doing it based on the meta tiles, we're doing it based on the X and Y count. I don't know if that's really necessary to do it that way. That's kind of a weird way to do it. Oh, yeah, okay, I remember why we did it that way. Sorry, this seems like forever ago that I worked on this, so okay. Well, it's all right. We'll leave it at 64. If I look at the memory, it's 40. That is a reasonable representation. Please, let's see if this... Oh, you can do number of columns. Yes. Oh, that's so good. So we can resize this so now it matches the width of the screen for the meta tiles. Yes. Okay, cool. That's exciting. So now what we should be able to do is when we're updating, when we detect that we're moving to the next row of meta tiles, what we should be able to do is roll over and update the memory here for this I'm just wondering about the whole situation with the no, that's okay. All right, sorry, I'm kind of thinking to myself here. I was wondering about, you know, the 7 versus 8 rows, but that shouldn't be a problem, because basically this is, we'll have to figure out if we can make it so that this doesn't need to be there in order to work. But let me just do this here. Nah. There. So that's our buffer index, because that's going to tell us where the current row of meta tiles is in the buffer. And with the, well, the good news is that the first row is going to, or the first value it's going to have is 0. So let's see, so load 0, oops, and store it into empty tile, empty buffer index. Okay, so that's that. And then get rid of that. What we need to do now is, instead of recalculating this every time, should be able to, depending on whether or not we need to go to the next meta tile row, we can either just look at the buffer meta tile info, or if we have to update it, we will actually do that, and we'll update the buffer with that, and also update the index for the buffer to handle that properly. All right, so one thing I want to look at here. So if the buffer is 0 and we minus 8 from that, and then so that's F8, and then we do an AND of 64 is what, 40. So F8 and 3F to do our bit rollover. We're going to get 56. So if the value is 56, then we want to subtract the value, or just make it 50. And that's again because of that weird issue with the counting being wrong and our buffer being 64 bytes instead of 56. But that's okay. We will eventually fix that, but I'll add a comment about that. Let's see, so here we are incrementing the meta tile row. Load A3, store A, M tile Y, so that's the internal tile Y count. We need to get the next location of meta tiles. So okay, so what we need to do is we need to load a empty tile index, empty buffer index, clear carry, subtract 8, and 3F to roll it over to 64 at the max, and then what else? So then if it's compare it to, was it 3.8? Branch not equal to skip update empty buffer index. Wow. So this is store load A 30. This is skip empty buffer roll. And we're going to store it into empty buffer index. Okay. And then we're going to say, okay, so store tile Y, and then we're going to load the new row, which means we're going to grab the map high value, and we're going to add the tile Y plus 1, and then we're going to store it in row M plus 1, and then we're going to grab the map's low value. So basically we're finding our way to the meta tile row. So cool. So now we have store A row mem, load A M tile Y, grab the internal row for the meta tile. Grab the internal row for the meta tile and multiply that by 4. Oh, I see. So wait a minute. Romem. What is Romem pointing to? I don't remember. It should just be the map info. Yeah, it is. Okay, so is this in low level still? No. So this is where we get the next meta tile, and then what we want to do at this point is we would want to store that into is X being used anywhere here? Not yet. So load X with meta tile buffer index, store A into meta tile buffer X, and then we're going to do a shift left of the meta tile value, and then okay, so let's just see if that didn't break anything. Probably did, but that's okay. Okay, that's good. That appears to be correct. Where's the map? And then we shouldn't get anything until we get to this H with the green, right? Okay, cool. So that actually didn't break anything, so that's good. So let's take a look at how our meta tile buffer is getting updated. It should be getting updated to match the, oh, you know what? It doesn't work if you don't increment the buffer index. And then at the end of that, we're all done, we want to shift that back down. So where does it check for the flag? Branch of equal to, okay. So load A 8, no, empty buffer index, set carry, subtract 8, and store it in empty buffer index. That should be good. And we don't have to worry about that. Boo. Let's fix that so that it actually stays within the buffer properly-ish. Of course, now we're adding all sorts of additional stuff that needs to be done, so it's kind of making this run slowly. It also appears to have broken our attribute update. That's interesting. Oh, I guess we shouldn't be doing it here, huh? Should be doing it here. Load A, empty adder index, empty buffer index, set carry, subtract 8 and 3F. Store, just keep it within the bounds that it's supposed to be in. Oh man, it's not happy about this at all. I'm wondering if it's why did that get broken? That's weird. Transfer A to X. Out here for a second. Okay, that looks better. So what didn't it like about this? So are we using X outside of this? I mean, we are, but I thought once we were done with it here, it didn't matter because we're just transferring A to X at that point. So the whole point was that it was trying to use this. I mean, it could just be the increment that's the problem. Hammer Fabian, hey, how's it going? this is just I mean, the initial load is working okay, but then kind of all hell breaks loose. And I'm reasonably certain that this is okay. What we can do is we can just say, let's see. So when we come into this, what we would be doing is we'd say, okay, we're at the next metatile row. So, oh, this is wrong. I thought I did that, but I wasn't sure. It should be set carry, not clear carry. And compare this, okay. And then, so we've reset the index there to the new index. So now we want to, let's just do it here. So we'll just store, not add or buffer index. What is it called? Metatile buffer x, load x with empty buffer index. So that's that, and then we can increment it here. And then at the end, when we're done, we take the index. Oh, well, we only need to do that if we actually updated the buffer. So this is also, let's get rid of that. Oh, that's adder index. Never mind. That's not. So, okay, so here we're loading it, setting the carry, subtracting 8, and rolling it, and if it's, yep, so that's good. And then we are using it here to update metatile buffer. That's fine. Then we are incrementing the index here. Okay, so then the last thing we need to do is, after we're done, if we've loaded a new metatile row, then, and so what's going to happen is some of this work that we're doing to get to this point, the Y value, or actually where we're updating row mem. Maybe we can't optimize this. Because row mem is already pointing to the right location. Well, regardless, if we are done with the attributes and we check our flag here, let's see, so skip mask change, that's done. Split mode, compare split mode, branch not equal, done with attributes. So at this point, let's see, so that handled one. Yep. Load this. Branch of equal skip attributes. If this is 0, then the flag wasn't set. We can skip modify. Okay, so otherwise what we need to do is, well, not here. So the next point where we're looking at this will be so this is, we're going to update the attribute. So let's do this. So if we've updated the meta tile row, then we've updated the attributes, which means we also need to reset the index for the meta tile buffer. So empty buffer index, set carry, subtract 8. And I think that's it, because I believe if we've done this right, it will have already rolled it over to the right position up here. So we don't have to do that again. All right, so we're not getting strange behaviors anymore, it looks like. So that's, no, I spoke too soon. We're still seeing some attributes not get updated properly. Why did that change that? Is it modifying the attribute buffer? I wonder if we're getting into a situation where this is some sort of wacky value. Let's watch some memory here for a second. So stacked one on top of another, we've got, this is our attribute buffer. Oh, that's so cool. It tells you that's meta tile buffer and this is attribute buffer. Nice. So, all right, so these are our two buffers, and what we should be seeing is they should be kind of having some sort of parallel updates, but this is skewed for some reason. This is not updating correctly. Like this should be going across the whole screen. Looks like it's getting some of the right values. Wonder if we're just incrementing this incorrectly or something. Let's go into the debugger. What's it? Empty buffer index. It's 80. Yeah, let's see what happens when it's read and written to. So let's start over and run. And when we load the, how come that's not, oh, because the breakpoint is turned off. That helps. All right, so let's reset the game. All right, we're going to see a couple of updates to it. Oh, that's weird. Okay. So there we're setting it to 0 because that's the current row that it's pointing to. And then, all right, so we're loading it here. Store a metatile flag. Load a metatile buffer index. Really? Okay. Yeah, so set the carry and subtract. So now that's, so A is the value F8, and then we're going to AND that, and we're going to get 38 and compare it to 38. So we're going to set A to 30, and then we're going to store that empty buffer index. So now it's 30. Load A with 10 hex and clear, and add tile Y. That's all normal. And then we're going to load the buffer index, which is, why is that 1? That shouldn't be 1, should it? That we just stored it after all that updating. Did I forget to store it? No, I store it here. Is it because we're at a new row? Oh no, it says the value is 30. Oh, okay. I'm looking at A. It loaded it into X. So 30 is, if we go to, we're going to see it update the bottom here. With 1. Okay, so it's the same value. That's fine. So now step through that and clear carry and add carry with temp, transfer that to X, and then we're writing the value 4 times as X increments. Okay, and then we're incrementing empty buffer index, which gets us to 31. Good. Let's just walk through this. We don't need the breakpoint, so increase Y, load the metatile flag. So we're now actually loading the attribute. Go to the next index for the attributes. Increase our Y, compare it to see if we're done. Next metatile. So that's the next metatile. So the buffer index is 31. So we're loading that into X. And we're going to store into empty metatile buffer the value 3. Okay. So far, so good. That looks, put a breakpoint there. Then we're going to store value 3 again. We're going to store value 0. We're going to store the value 0. Store the value 3. Value 3. Value 1. next time around, the meta tile buffer index is not correct. Okay, so why did it not? I'm going to have to start organizing these things into a little bit more easy to read sections. But anyway, so it's not doing update attribute mode. Okay, that's probably why. Well, I mean, it should have gone into that. Branch not equal to update attribute mode. Otherwise, skip modify attribute index. I mean, that should have been enough. Let me set a breakpoint on that. Let me restart here. Update attribute mode. Okay, so put a breakpoint there. And then we will put a breakpoint on, where are we doing this? This is so much easier to use, this debugger. This is so good. All right, so start rather. So if we go back to our memory, and we go to the address that we are looking at, it's going to update this row here, or it should. Yep, so we're seeing the 133003331, and then MT buffer index is 38. So we're going to subtract, set carry, subtract. Oh, seriously? Dummy. Store it. Right? Doesn't matter that I subtracted 8 if I didn't store that in memory. All right, let's turn off these breakpoints here. I don't know why these attribute updates are wrong now, but let's see how this is going. Well, so this is, that's not right. And that might explain the attribute problems. Why on earth? Let me start over here. Okay, so the value of buffer index is, empty buffer index is 38. We're going to subtract 8 and we're going to store it. Next time around, it is 9. No. That's not right. That should not be a value that we get. $38, so we subtract that, and it's now 30. Then 30 is 56. Or sorry, 38 is 56. So 30 is 48. So now the next time around, when we do that, empty buffer index is 30, right? So load X with that, and we increase it, and we do our thing, and then it's 31, and it's 32, 33, 34, 35, 36, 37, 38, and that should not be a value that we get. Compare with 38. Why is that happening? Why are we getting... Let me think about this for a second. So the first time around it's 0, and we subtract 8, and we get minus 8, which we don't acknowledge as a valid value. So we're getting F8, and then we're ANDing it with 3F, and we're saying, okay, if you have 38, then the value is actually 30. So then you add 8 to that, and you get 40. Oh, wait, so it shouldn't be 30. No, sorry. It gets reset to 30, and then you add 8, and you get 38, and you subtract 8, and you're done. And then the next time you come in, you get 30, and you subtract 8, and you're supposed to get 28. Why is that not happening? It's obviously because I did something stupid, but I'd like to find that now, please. Let's reset this and take a look at the time when we're actually doing the subtract. So the value is 0, so we're subtracting 8 and getting F8. We're doing our and we're comparing it, and we're saying, okay, it is equal, so we need to set it to 30, and then we're going to store it. And the value is 30, which means we're good now to go, and we're going to start with it being 30, and we're going to 31. Let me do this so we can look at x. So x is going to be the representation of that 31, 32, 33, 34, 35, 36, 37, and that should be the last one. So y is 1, 0, which is what it should be because we're at the end of updating the screen, or the name table specifically. So now let's look at the meta tile flag, and it says that it's 1 because we actually updated stuff. So the buffer index is 38, and we're going to set the carry and subtract 8 and store it. And now it's 30. And that's what it's supposed to be. So now the next time around, x is 30, 31, 32, 33, 34, 35, 36, 37. Oh, should it be 30 at the end? Yeah, I guess it should be 30 at the end. Let's see, if we were at row 0, we're going back 1 row, so it would be 30. And then once we're done with that, the next one, yeah, it should be no, that's actually not right. Why did it not call this? Oh, wait a minute. Okay, so I see what I'm doing wrong here. So I'm doing this processing here for my buffer. This has to happen with every sub row, so every one of 4 rows in the meta tile, this part, but this doesn't have to happen every time. So what we need to do is load a what did I call it? Attribute flag or something like that. Yeah. I set the flag that says meta tile flag that says, yep, we loaded a new row of meta tiles. Branch not equal, branch equal to skip empty buffer load. So we only need to do this occasional. We only need to do this when we've actually loaded a meta tile row, which is why it was not working. It was loading it too many times, and then that's why the index was off. So let's see if that fixes it, and then we'll wrap it up for tonight. Breakpoint is the wrong spot. It should be over here now. Why is this breaking? I don't know. What did I do? Load. Oh, yeah, I can't do that because that breaks the... Compare x with 1. Branch if not equal to that. All right. I can't update A like that because that breaks the meta tile loads. Yeah, so all of these things I'm adding, of course, are adding time to the processing, which is what's causing that weird jittering that we're seeing. And of course, this is still not working exactly right. Let me do this. I think what I can do is I can move this here. Yeah, because what we're... This will work. Well, not exactly. Load A, row mem Y. Okay, that'll work. That'll reduce the requirement to check that flag multiple times. I was doing it up here, but I just realized, well, we've got to check it here anyway to determine if we're updating the attributes. Let's see if that fixed some stuff. Okay, so it's not quite as bad. Is the memory updating more correctly now? No, it's all screwed up. It's still all screwed up. Well, this is wrong. That should be happening here. Okay, that's less bad because we're seeing the changes kind of move along with the level. Oh, Y got incremented already. So this is a problem. Let's see. Can you do it? Is that a thing? So I'm decrementing Y because I actually want the previous value, and then I'm re-incrementing it. That's why it was showing weird values. Really? Oh. I said I was re-incrementing it, but I'm not actually doing it. I'm sorry, I'm beat today. I've had a long day. I'm just making silly mistakes now. Okay, so this appears to be doing what it's supposed to now, where it's actually doing updates of that memory correctly. What's going on with the attribute memory? Was that looking okay? It's not perfect, but I have to look at why that is. That may all come down to timing here. I may have to reevaluate this because this doesn't seem like... It seems like it's less efficient than I thought it was going to be, because now we're updating 2 locations with the memory information. And we do have... a relatively solid way of looking up the information about the meta tiles. But the problem is that it still doesn't give me the collision information like I wanted. Like I can't look at just one row at a time. So I do need a in-memory map of what tiles are loaded. And then the question is like, okay, how do I do that within the confines of this in an efficient way? Because obviously it's adding too much time now, which is why we're seeing those weird blips on the row loads. And my guess is that that's also somehow impacting the attribute update. Crap. All right, well, we'll see what we can do for next time. I think probably what we'll have to do is reorganize some of this code to make a little bit more sense, because right now there is kind of too much going on to make sense of reasonably, to figure out how to kind of load this in and make this more efficient, because it's just kind of a run-on of code. I don't want to make jumps to subroutines because that's expensive. It adds quite a few cycles, so I might isolate things into separate files maybe, and then use that to kind of organize things a little bit better. I don't know, we'll see. That'll be what we do next time, I guess. I mean, we got the sprites loading our that's weird. We got the sprites loading the into the char ROM properly, which is good. And you know, that was the other reason I used source tree to take a commit of what we had previously, because if we got to a situation like this where potentially we can't figure out what's gone wrong, we can always reference what's changed and potentially revert back. So as always, if you have any questions, feel free to reach out to me on Twitter at Clairvis. I will post the recording on YouTube, so you can feel free to comment there. People have been doing that, which has been excellent, and I certainly will try to answer your questions as quickly as possible. And yeah, sorry this one was a little bit of a mess, but like I said, I was tired and kind of wasn't I didn't have a real good game plan coming into this, so I'll think about it for the weekend, come back to it Monday, hopefully have a better plan, and it'll come together like the rest of the stuff has, and we'll be able to get these submetatile collisions working properly. So thanks for watching. See you next time. Have a great weekend, and see you Monday.